Sanjeev, you can start, I guess. Okay. Good afternoon, everyone. Unfortunately, our respected Director General of Shipping, Sri Amitabh Kumarji, has expressed regret for not able to join the meeting due to some ministers' meeting or call. Unfortunately, he is not able to attend, but he has sent his good wishes and blessings for this course. So, good afternoon, everyone, and welcome to all the dignitaries and ladies and gentlemen. Warm welcome for this inauguration of the much-awaited one-year online program in ship management and logistics for the people associated with the maritime industry. Institute of Marine Engineers India and Narottam Morarji Institute of Maritime Studies have jointly launched this course after a lot of effort and hard work. It is scheduled to commence from 5th of October this year. We have received tremendous response for this program and queries numbering more than 100 which have been answered. So far, 17 candidates have duly registered, one of them from UAE and the rest 16 from India, 4 of which are sailing engineers. We expect a lot more in the coming week. So the main objective of this program is to bridge the gap between the existing techno-commercial knowledge of our mariners and industry standards. This program will enable candidates to develop managerial skills and lay the foundation in different aspects of maritime management. This course is specially designed to give candidates an exposure in the field of finance, budgeting, and the commercial aspects of shipping. Furthermore, this is a one-year training program consisting of 2 semesters, which will be conducted only during weekends, that is Saturdays 3 to 6 p.m. and Sundays 10 to 1 p.m. The exams for the first semester will be conducted in February of 2021, and on conclusion of the first semester, there will be the second semester exams on the conclusion second semester. The exam will be in June 21. But people who are not able to give the exams in February, we will be flexible and can arrange for them to give both the semester exams in June. The course will enable seafarers to apply for attractive seashore jobs as part of distance learning program. The course will be conducted through online virtual classes, giving candidates the flexibility to undergo this course from the comfort of their homes. In addition, digital study material and lecture recording will be provided for candidates who are unable to attend lectures due to sailing or professional commitments or any other such constraints. This will further enable candidates to revise the course content and get a complete understanding of the same. The course is designed and developed by top industry professionals. The currently designated faculty members are among the best from the industry, including Dr. B.K. Saxena, Captain D. Gautama, Mr. Dinesh Kutty, Mrs. Sonal Satlelkar, Captain R. Swaminathan, Captain R. Bhargav, Captain P.B. Zog, together with other specialists and management gurus. This specialized course will benefit all who wish to pursue growth in their careers and look forward to joining any logistics company, multimodal transport company, freight forwarders, and custom house agents, insurance and risk management companies dealing with hull, machinery, cargo, and third-party liability insurance, ship and chartering brokers, ports, export-import houses, trade associations, inland container depots, and container freight stations, government departments, and law firms dealing with shipping and related logistics, etc. Candidates who have chosen to enroll for this course can be rest assured that they could not have made a better choice than this. It is going to be an amazing and fruitful experience for all of them. Lastly, I would like to express my gratitude to all the members of IMEI who work continuously to make it happen. We are also thankful to everyone on this platform today for taking time out to attend this inaugural function. We look forward to your active cooperation and feedback towards any areas of improvement. Having said this, would now request Mr. Uday Purohit, President of the Institute of Marine Engineers India, to formally welcome the dignitaries attending today's inauguration. Uday Purohit.
Ladies and gentlemen, good afternoon. We've got a lot of dignitaries here. I won't name them, but a very warm welcome to all of you. Let me start off by commending the Mumbai branch for an outstanding job in putting this course together during such trying times. I know Vijendra has been pursuing this with his team for the last almost a year, and he's done that with a single-minded focus. Thank you to Sardul Singh, Captain Korea, and everybody at the NMIS to actually take this step forward. I think it's a big leap in terms of what this course can achieve. So there are three things here that in my mind, it aligns with. One, it aligns with the Institute's vision to go digital.
Sir, your voice,
That means,
Uday sir, your voice, can you just put the mic in front, please?
so can you hear me?
Yes, now better. Thank you. Sorry.
Okay. Okay. So I'm saying that the course is going to, in my mind, align itself to three important factors. One is the Institute's own vision of going digital, of bringing extremely high-class education to the marine engineer. And number three, it also aligns with the Maritime Vision 2030, which the Minister of Shipping, under the able leadership of Sri Amitabh Kumar, has rolled out. So I think from all these three perspectives, having this course makes so much sense. A big pat on the back again for the Mumbai branch. 17 entries so far. We've got somebody from Dubai. We've got sailing engineers. We've got guys from all over the country participating. I think COVID has made it possible. And in many ways, COVID has been the biggest transformation agent in our lives. So once again, best wishes for this courses. Mumbai branch, you've done a great job. NMIS, thank you for supporting this initiative. And I'm sure this will go from strength to strength. Vijendra, my personal thanks to you. I know the way you've single-mindedly pursued this. And if you had told me 2 months back that you would get 17 or 20 candidates for the first course, I would not have been so optimistic. So once again, hats off to the team. Welcome everybody and best wishes for this course.
Many thanks, Udayji. We would now like to request Chairman of the Narottama Moraji Institute of Maritime Studies, Captain Pradeep Korea, who has currently taken over the lucrative position of Chief Operating Officer in Seven Island Shipping Company after extended and successful stints in Varun Shipping and the Great Eastern Shipping Company. He has been a colleague for 13 years and remains a close friend. NMIS has given a lot of help to IMEI to realize their goal of bringing this program to a reality. Without further ado, over to you, Pradeep.
Thank you, David, my dear friend. Thanks a lot for the welcome. Good afternoon to all my friends in the maritime sector. I think David and Purohit Saab have said it all, but as part of protocol, let me also say a few words. It's immense pleasure to be present here today to see the commencement of two great institutions join hands in this competency build-up. If 3 years ago I read Maruti Suzuki collaborating with Toyota, I thought it was a very unfamiliar move. Today, we realize how important the combined strength of navigation and engineering can do wonders. With available technology and skill upgradation, there is no limit to growth of oneself, the entity one is working for, and hence this opportunity can create wonders for professionals. I am bullish and confident that both IMEI and NMIS will prove the future with collaborative initiatives to chalk out other exciting programs, courses to meet the needs of the sector. I wish to thank Vijendra Jain of IMEI and Dr. Saxena of NMIS and all my GC members who have made this program happen, and wish NMIS and IMEI all the very best. Thank you.
Thanks so much, Captain Korea, for all your warm words and good wishes. We are sure to see huge success with this course and all our joint ventures with NMIS in the future. There's a slight change in the program, and this inauguration would not have been complete without a few words from the person who has been the prime catalyst for the success of this course, Dr. Vijendra Saxena, who is a doyen in maritime education and training sector and has been the founder principal of Tolani Maritime Institute and now continues to be associated with it as an advisor post-retirement in 2018. He is chairman of Training and Research Committee of INSA and also member of the Governing Council of Indian Maritime University. Dr. Saxena, a few words from you, please.
Thank you, David. I hope people can hear me clearly. Good afternoon, everybody, and welcome to this session. I am indeed not only happy, but feeling a little quite satisfied, actually, because this was an idea which we discussed, I think, about 1.5 years back, myself and Vijendra. Why not, do something like this? And finally, that is materialized, and I'm indeed happy. This, I've got a little, I'm on both the sides, because having been the president of IMEI, and of course, I'm part of IMEI, but I've been associated with Narottam Moraji for the last 35 years. Okay, because I had done the course there way back in 84, 85 or something, and then faculty member, then being on the board, and now again I'm there, and I'm the chairman of the academic council, and therefore I was able to sort of move this forward, this idea forward, but it couldn't have been where it is today, but for the support of course, Captain Korea, being the chairman, and literally pushed the thing, yes. And another marine engineer who is also on the board, Rajesh Joshi of NMIS, and Sardul Singh, another IMEI member and present here, who was the director of NMIS that time. And all of us, we worked together, and we made this possible. See, the thing is, a ship owner operates a ship, either on liner terms or voyage charter or time charter, and he obviously looks for a decent returns on his investment. But this objective can only be achieved if the shipboard staff, especially the senior shipboard staff, and the people, the technical people who are supporting from the office and other support staff, understand the requirements of the business. Okay, may not be to the depth which is required, but at least enough so that they can contribute and make sure that the objective of the ship owner, who has invested lots of money in buying that ship, is finally achieved. Okay, and this kind of a program which we have designed together will be a very good platform to provide that kind of a knowledge and skills which are required. For the benefit of so many friends who are there, and it is so nice to see so many faces and friends there. Just tell you a little bit about the program. You see, of course, it is 2 semesters. The first semester has got 4 subjects: principles of management, shipping practice, the law of sea transport, and costing and budgeting. So the legal aspects, the financial aspects, and awareness of the shipping, plus the managerial thing comes in the first semester. The second semester, there is a basket of electives. There are 6 electives, out of which 2 have to be taken. The first is economics, maritime economics, then the ship management, logistics and multimodal operations, chartering, marine insurance, and finally maritime regulations. So that is the spectrum, and I'm sure you are able to appreciate that it's quite a good mix of everything. And I'm happy that about 17, 18 people have already enrolled. And I'm sure the experience is going to be not only excellent for them, but it will definitely benefit the industry, the fraternity. And I would urge the industry doyens, all the people who are currently in positions where they could influence decisions, they could ask their staffs or sailing staffs or anybody who could come in and take benefit of this unique advantage, unique initiative. So compliments to Vijendra, who has been, constantly after me, and and then we have worked together, and so thank you, everyone, and I'm sure the course will turn out to be very, very beneficial to everyone. Thank you, gentlemen and ladies.
So So thank you, Dr. Saxena, for all the encouraging and enlightening words. We are indeed obliged to you, sir, for all your efforts. Unfortunately, DG Shipping respectable Amitabh Kumarji is not here, but indeed he has sent his blessings and best wishes for the inauguration and indeed for the course. He has always been encouraging and innovative and big support for such value-added training in the maritime sector. So we are deeply obliged to him and we miss his presence today. So with that, I would like to thank everyone for being present and would like to hand over the mic to Mr. VK Jain, Chairman of the Mumbai branch of IMEI, for the vote of thanks.
Thank you, David. Lot of thanks, but since I have to do this formal vote of thanks, let me get on with the job at hand. Captain Pradeep Korea, Dr. BK Saxena, Mr. Uday Purohit, esteemed guests present here today, Mrs. HK Joshi, Mr. Ajoy Chatterjee, ladies and gentlemen, I am humbled and it is an honor for me to propose this vote of thanks. The IMEI had declared that it will be conducting this course on 7th December last year at a small function in Hilton Hotel, which Captain Korea had also attended. At that time, little did we know that it's going to take us 10 months to set this up. I'm therefore doubly happy to be proposing this vote of thanks today. A thank you to Captain Pradeep Korea, who has been unwavering in his support to this program. His positivity as the head of the NMIS has been essential for us to be able to bring this course to you. Thank you to Dr. BK Saxena, the head of the Academic Council of NMIS, who has personally been a pillar of support to me throughout. His encouragement during the last few months when things didn't seem to be going the way we wanted them to, in addition to his guiding us through the syllabus and the structure of the course, has made it possible. A special thanks to you, Uday, for your unflinching support to drive this initiative through. Thank you to Dr. Dhingra, who has, during a short span of taking over as the director of the NMIS, been able to get the MOU finalized and endorsed. We look forward to continued cooperation with you, Dhingra Saab, in the times ahead for smooth running of this course. Thanks to David Birwadkar, who has spontaneously undertaken the overall responsibility of this course under his subcom. There has been a lot of work done by him, and I'm sure there is a lot more ahead up for you, sir. Last but not least, I wish to convey my heartfelt thanks to Mr. Sardul Singh, the ex-director of NMIS. His passion to deliver this course enabled all the nitty-gritties to be worked out smoothly during his tenure, and he brought the whole project to a stage of finalization. The business plan, the proposed MOU, the subjects, the modalities of how this course will be conducted were all due to his single-minded devotion to produce something for the benefit of the industry. Thank you, Sardul sir. A big thank you for all of those who have supported this initiative and helped in disseminating the information to the fraternity. I am sure with the best of the course content, which has been perfected by NMIS over the last 4 decades, the best of the faculty who will be delivering this course, and with the commitment of IMEI, the cadets, the candidates who have registered will stand to benefit tremendously. I'm also hopeful that this course will grow in strength and become a marked date for students who wish to enroll and learn about different aspects of commercial shipping in the future. With the permission of NMIS, we will, as an exception, extend the registration date into October for this inaugural course. Thank you all once again, and Jai Hind.
Thank you, everybody.
Thank you. Thank you, Mr. Jain, for those kind words. Thank you.
Thank you, sir. We will now await the start of the second part of our session, and we will. That's a technical session on ship energy efficiency. I will now hand over to Sanjeev Mehra to so that we can move on to the second part of the session.
You'll excuse me, I've got 2 other meetings lined up.
You'll have to excuse me too. Thank you, all the
Thank you.
organizers. Thank
Sanjeev, you can't go now.
I came out of the meeting.
Thank you all. Thank you, sir.
Thank you, Jay. Thank you.
Sanjeev, I suggest you wait for 5 minutes because we are a little early. People who are scheduled to join at 3 o'clock, we don't want them to miss out on it.
Thank you for all your support.
Sanjeev, you can let me know when you want to start. I will start reading out from this.
Yes, so I'm just, okay. Dr. George asked to unmute. I think we can start, sir.
Start?
Yep.
Jen, we start?
Yes. Hello. I'm here.
Points first. Show those points first. Your highlight points. Keep mic off.
Right, sir?
Yes. Just a moment. I need to share my.
No, Dr. George, just a minute. We will let you know.
Okay.
David, sir, can we start with the Aakruti slide, please?
Okay, you can put it on. I will read through it.
Yeah. Okay, sir. Over to you, sir.
Yeah. So this webinar is being supported by Aakruti Enterprises. Brief introduction for Aakruti Enterprises. They are a proprietary business house in Goa, operating in the field of marine supply, commissioning support services, and industrial engineering services. Established in 2005, their customers in merchant ships. They have sales and service offices in Mumbai, Maharashtra. Their vision is to be one of the most trusted business partners delivering consistent and reliable services to maritime industry in India. Mission, they want to be a solution-driven company in the naval shipbuilding and mercantile marine segments with credible record and consistent performance. We strive to be innovative, they say, IT-enabled and process-driven company, and would like to be recognized by the industry for the kind of services they deliver. The group companies include Aakruti Enterprises, which has marine business solutions, trading on Bison products. Aakruti Trading Company, trading in electrical goods, electronic goods, and engineering products. Zantaye Ice Factory, ice production and distribution in Northern Goa. Zantaye Civil Contractors and Consultants. Snitch Industries, FMG vertical. Value-added services to the shipping sector. Their aim is to provide value-added services to the shipping sector by enhancing their domain from naval warships building to commercial shipping industry. Towards this, their aim is to bring cutting-edge technology by partnering with global technology leaders. Thank you so much, Aakruti Enterprises. With this, we start our program, and so good afternoon and a very warm welcome to all the dignitaries, ladies and gentlemen, for taking time to attend this webinar on a very relevant and important topic in maritime industry, namely ship energy efficiency, conducted by the Marine Mumbai branch of Institute of Marine Engineers, India. It is an absolute thrill to be here with all of you, and my privilege and honor to introduce our guest speaker, Dr. George Antunes, directly from Portugal, who has a huge list of credentials to his name. I was amazed when I went through it, and it's really mind-boggling when somebody sees so many degrees, so many credentials to his name. So to start with, he was born. Dr. George is born on 18th of July 1961. He completed his bachelor's in marine engineering from Infante Don Enrique in 1988, followed by a certificate in marine engineering in options, offshore vehicle design and drilling engineering from the University of Newcastle upon Tyne, England in 1991. He completed his Bachelor of Science in Naval Architecture from Technical University of Lisbon in 1992 and Masters in Marine Engineering from the University of Newcastle upon Tyne, England in 1992 again. Dr. George completed his Doctor of Philosophy, PhD, degree from Sir Joseph Swan Institute, again, University of Newcastle upon Tyne, England, and he did it within the years 2003-2007. Dr. George has vast experience in ship performance and ship fleet energy management and audits since 1995. He also has a huge experience in diesel, sorry, 1 minute. Huge experience in diesel, auto, and gas turbine technology, working as a consultant to some of the major engine manufacturers on dual fuel engines. He's a designer of ship performance monitoring systems and alternative fuels such as emulsions and gaseous fuels on conventional engines such as hydrogen. His main interests include ship energy efficiency and has published three papers in international conferences: ship performance at sea, heat recovery from low temperature heat sources, ORC, thermionic generators, gaseous fuels as marine fuels, hydrogen production and liquid carriers, gas engine, and has 2 papers published at the International Journal of Hydrogen Energy. His professional associations and recognitions include, oh my God, being Portuguese Engineering Council member, ASME member, recognized specialist in energy audit by the Ministry of Energy of Portugal since 1991, member of the Institute of Marine Engineering, Science and Technology since 1998, member of COGEN, Portugal since 1996, member of the Portuguese Association for the Hydrogen Development since 2010, member of the Portuguese Naval Industries Association since 2010. He's also a winner of Sea Trade Green Shipping Awards in 2012 and Innovation Green Projects Award in 2018. Dr. George is currently working as Technical Director of Techno Veritas Services of Engineering and System Technology Limited. He has been associated with them right since December 1994. He is also an evaluator of European Union EDGE 2020 projects on ship energy, green shipping, and hydrogen. With such amazing credentials, it is but appropriate to have Dr. George Antunes share his insights on this topic, ship energy efficiency. We just cannot wait. Over to you, Dr. George Antunes. Thank you.
Thank you very much, everybody. Hope everybody is well of health. So these are new times, and this is a great opportunity to speak for such a vast and interested people. I really hope that I may manage and fulfill your expectations. The thematics. In fact, these are 2 presentations in one. These are 2 vast subjects to talk about, and in such a small period of time, 45 minutes. Hello? Hello? Okay, I will start immediately. I'm going to share the presentation. Are you watching the presentation right now? Yes, I believe so. Hello?
Yes, Dr. George.
Okay, can I proceed?
Yes, Dr. George.
With the presentation. Okay, thank you very much. So once again, bear with me. This is a very long webinar, so is a 2-in-1. I'm sure that a lot of questions will be on the air after this, but you are free to contact me, and I will be very, very much happy to reply to all of you. So digesting data to access fleet performance. So the company is now a 26 years old company dedicated to fleet performance. We have a number. We created a number of tools, namely the BOEM-S and the VEEO, and the VEEO and BOEM-S were the winners of the Sea Trade Awards in 2012, here with the IMO Secretary General at that time and the American ABS, American Bureau of Shipping, on the left. So it was a great achievement, recognition. Then more recognitions for innovation with the Green Projects Awards. with emulsification of systems, emulsification of fuels to reduce emissions of NOx and particulate matter. We had a big project at Madurai Power Station, great people there. We do also engine performance, and we do our own business, our own equipments, like a torque and thrust meter that is our baby in terms of ship performance. Okay, so in terms of fleet performance, we developed and we identified a number of main streams that were really requested to address: the voyage performance, the hull and propeller performance, main engines and systems performance, maintenance performance, and main engines and systems performance. So the thing is, people needs to have the information, and in fact it is very much in accordance with your fantastic course objectives. So the one that does not measure has only a vague idea, and what is happening most of the time is that people on board are too busy with smaller and smaller crews. Crew members are not adequately trained. Crew members may not be really interested, resulting in data inaccuracies. Crew may not see data monitoring as a friendly operation, but has a big brother type of thing. Vessels operate under different weather conditions, therefore requirements for correcting data are very important. The results generated should be accurate, and most of the time they are not sufficiently good to engage crew and shore personnel. Vessels performance is a very wide concept that is dependent on human behavior. So, but not only the people that is on board, but also the people that is operating the vessel, and where the vessel environment and how the vessel environment is, the market environment, and also the technology level on board the ship. So typically, how can we implement a system? So we need to select which are the systems on board the ship, but also ashore, that we need to monitor, okay? Which are the systems, which are the variables, and which are the conditions that we decided to keep as a standard for comparison. To perform a comparison, we have to have, a baseline. So which are the conditions that become the baseline, and which are the conditions at sea? To collect, we need to ask from where, and which is the frequency we want to have the data collected. Also the processes, which are the processes that have more impact on, for example, ship efficiency itself. What are the processes that impact the ship operation, okay? So this involving already the port operations, for example, agents, authorities, stevedores, whatever. And also we need to filter, the process to filter. So we don't need to know, not all the data is information, but information is inside of data. So we need to understand this. Then we need to exploit how to identify, how to interpret, how to compare, and to who we should distribute the information, and have proofing that our information, the information that is being distributed, is valuable for the persons or agents that receive the information. Then we in the next step, we may get the prediction and the forecast for example, for dry docking of a ship. When, according to a certain model, when should I dry dock the ship to clean the hull, for example, and to have the evaluation. And in a more advanced step, we may anticipate. So we need to have pro-action and evaluation again. So how to implement a ship performance monitoring? So we need to identify the key variables that are the ones that affect the system performance. Select the minimum number of variables to be cheap. So we don't need to measure and have sensors all around the ship, only on the systems that have bigger impact. How the variation of key variables affect some system performance. Monitoring conditions, very important. Which are the variables the range of the variables where we should have thresholds, alarms. So we need also to define alarms for each one of these variables as they impact the ship performance. How to interpret the variations of these variables. So this needs skilled people, expert systems to understand and to interpret the message that the variables and data is giving to us. Then in fact, what we are doing is VEEO, that is a Voyage Energy Efficiency Optimizer, is collecting the data and is sending it to the cloud. That in the cloud, we have a toolbox for ship management that is called the Blue Overall Efficiency Monitoring. So the idea is to connect people in the two ways, so ship to shore and shore to ship, and virtually to work in real time. So the systems have been audited and have certificates of design assessment, etc., etc. We have quite a number of, in fact, we specialized in cruise ships. We started with tankers and container ships but then in the last years, we did some specialization on cruise ships and warships. So onboard data acquisition. In fact, the people on board should be empowered and should be engaged on the emissions of ship, okay? On the level of energy the ship is operating. So people need to be assisted to have data in real time to support the decision of the captains to and also chief engineers to lower the emissions. So ship performance system, VEEO has a special human-machine interfaces for the chief engineers and for engineers, and also for the bridge, for the captains and pilots. So, for example, here we can see the emissions of each one of the generators that, in fact, in the big container ship may be very, very high, because container ships, they may have 2 or 3 up to 5 megawatt diesel generators to electrify the cargo, the fridge containers. So the idea is to have a ship to shore and shore to ship communications that in fact it is something like this. So the shore, the fleet management team and the crew on board are connected in real time. And we may have here a basic quantity of variables that we define as being important for the ship operation. We have these dashboards to be in real time at the bridge. We can see here atmospheric conditions and also the voyage, and also these are how to say, important for the reports for MRV and IMO-DCS. So the software includes this optimal trim performance, fuel management, MRV reporting, cargo plant performance monitoring, boiler performance monitoring, and historic data. Also, for to avoid fuel pilfering, we have our system that is really controlling the quantity of fuel that is being burned, so, and the quality as well. and the system is changing from open sea to ECA area or SECA area. Okay, has a business assurance tool. So we need to understand on the shipping companies that we need to have an assurance tool. So this is what the people ashore see. For example, the ship is organized in the sort of a tree with all the weather conditions, performance conditions, ship monitoring data. But on top, we have voyage optimization, maintenance management, purchasing, reports, documents, small repairs, and crew management. So, in fact, I'm not going to take much longer on this, except that we are now using the reports and documentation that is fantastic, and the maintenance management tool as well. So these are really good tools, as they allow people to be aware of when certificates will be out of date, to arrange for the surveys, etc. The purchasing, very important as well for the ship departments, and the VEEO for small sudden requests of repairs on board. And we are now using the QR code technology for the ship electronic logs. So this is intuitive, has these three is arranged as you see your ship. Not so the big advantage of this BOEM system is that you manage this as you like. So you see exactly the ship as you see it. For the technical management, for example, for performance monitoring, you can assess all these trees, and we also have vibration readings online. So for diagnosis, for example, engine cylinder diagrams. Our system is exporting the diagrams for BOEM, and people ashore may help on the diagnosis. Also, voyage optimization. This is nothing new, but on this voyage optimization, we have something that may generate a simulation of a certain contract, as we can. This tool requires the voyage cost to be input, and then choosing the route, we can manage which is the best route to get the best results. All the taxes are to be put in, then the simulation results, the economical simulation results, will be adjusted according to the route that the ship is going to perform. Then we have reports and documentation, voyage reports, SEMP reports, whatever, machinery manuals. So everything is available online at the click of a button, as well by phone. And then these are very important. This is a very important tool to get the reports done for MRV and IMO DCS. Data management. So we have all the variable reports, known reports. So you may manage to have your, you may have your preferred variables displayed here. For example, this is the loss of here is the loss of speed as a function of time, and so then here we have the increase of fuel consumption as a function of time. So you can manage the dry docking at time. So the specific fuel oil consumption, the thrust and speed as a function of time, and the specific fuel oil consumption as well. And here we have a very important thing that, as I mentioned, as we have the capability of measuring the thrust that the propeller is producing, then by knowing the ratio of kilonewtons per kilowatts that are being delivered to the propeller, we may monitor the efficiency of the propeller. Okay, so by setting up one alarm, then we know that we should clean the propeller or we should clean the hull. Okay, so we can pinpoint where is the inefficiency. If it is on the hull, is the hull dirty, or is the propeller dirty, or is the machinery, the propulsion plant not delivering the right power? Okay, so we have the consumption, for example, the consumption of fuel per hour or per nautical mile, etc. So hull resistance degradation is very important, in particular that for the new regulations. Assess your fleet performance instantly, and this it allows also to produce the benchmarking. Okay, so now we are going. So this was the presentation of one of the tools that we have been installing on board passenger vessels and warships mainly. Part 2, shipping and the dilemma of low carbon emissions. I believe, my friends, that shipping is just about to change overnight. What I want to present now in this part is what are the social costs of emissions. Everybody knows, or that is the general idea that nuclear power stations problems may kill a lot of people. But how many people around the world is having lung diseases? How many cancer lungs exist around the ports? Okay, so how to control also the CO2 emissions? And I will be focused on the cap and trade. Shipping, everybody knows that is the most efficient mode of transportation. But how large are the shipping emissions? You will be surprised for the ones that are not aware of this. The regulating bodies, European Union MRV versus the IMO, EEDI, and SEMP. So this is a big game, and in fact, I have to be honest with you. European Union is making a lot of effort to control emissions and to incentive the efficiency of the shipping. Okay, then you will see types of EEOI. And when I'm referring back again a little bit, when I'm referring to IMO, I'm not saying that IMO is not making its own effort, but the big players, the lobbyists, are making a lot of resistance to change. Okay, so everybody wants to stay, or most of the people want to stay in the business as usual, and this is not possible anymore. Then types of energy efficiency of operational indicators. So this is an IMO defined indicator, and so many people use different indicators as per their own wish. Okay, so the difference between commercial design and real world indicators, I will show that to you. How can shipping be less harmful to environment? That is another question. Reducing CO2 emissions through efficiency improvement. This is great. Energy requirements of ship and its consumption, the future of marine fuel path, and the fuel mix. So in a very close, very short time, we will be looking at fuel mixes, and we need to be flexible sufficient to accept whatever it is on the market, but it is on the right it is right for our ship and our environment. So we are a CO2 verifier recognized by the European Marine Safety Agency. So right now I will be speaking somehow with the authority of a verifier, okay? As said before, we are a specialized company on energy efficiency. We do big data and assets optimization, fuels experimentations, engine lubrication, and hydrogen. We are very much here around Europe. We have a special program that was launched about 20 days ago from the European Union to implement hydrogen as fast as we can. So challenges. We had the Paris Agreement, already in 2015. Everybody was happy, but nobody accomplished it. So this is a little bit dodgy. So everybody agrees, but then the market is not responding. Then we have the targets defined by IMO, 50% by 2050 regarding the emissions from 2008. But then we have the European Union's goal is to reduce 50% by 2030 and towards 55% compared to 1990 levels of emissions. This is extremely difficult, and the European Union is only delivering or throwing money to the industry after this pandemic that is oriented to emissions reductions. So it doesn't look like, but in fact, the bigger polluters, the bigger emissions come essentially from container ships and bulk carriers. So, and container ships are connected to the business around the world. Okay, so there is a big mistake here, that is, people are bringing containers, boxes full of goodies from China, essentially, to Europe, and then the vessels are going back from Europe to China completely empty. My friends, this is just about to change. Europe is really making a big effort, and I believe China will have in the next years, the life a lot more complicated because they realize that this is not sustainable. So comparing the whole emissions of marine emissions with the rest, then we see that we maritime business, we are emitting just about the same as aviation, okay? And here on the aviation, there is a big change as well, because short flights will be ended at least in Europe. And in fact, what is accounting for the bigger parcel is to the road emissions. So the vision of European community is 27% of total EU green gas emissions that come from transport must to reduce to 27%. So the idea, again, from one holistic point of view, so there are very well-defined routes of trading. Then we know that 70% of sea transport in the world is transshipment to hubs. You can see, so you have one big point in India, then the routes are very well identified. So everybody around these areas of these routes here, I am here, you are here, okay? But here we have a huge number of lung diseases, okay, due to this route that is just along our coast. Okay, so these lung diseases and asthma and all that type of diseases, they have a cost for the populations, okay? They have a high cost for the populations and high cost for the governments. Also, when we are pointing the finger to the ship and its operation, we need also to see that there are a lot of other stakeholders on the ship operation that have their own, percentage. They are also implying inefficiencies of the ship, or they are making the ship to stay more time in port or arriving earlier because the ship that was doing unloading was delayed, so they have no port to come in, so they have to stay nearby at the anchorage waiting for their slot. So this is just to mention, we need to be very careful because there are a lot, and I was really surprised and happy to see that the Institute of Marine Engineers is going to produce this fantastic course with this fantastic syllabus, as there are so many implications. I hope that you will focus on this, on the on the greasing of the gear, of the shore gear that is engaging the sea gear, that is the ship, in terms of operation. I hope that you will address properly these themes on your course. So shipping emissions are expected to increase 5% due to the growth of international ship traffic in the Northern Hemisphere. This was prior to COVID. Believe me, we usually have around 350 ships along our coast during one day in 24 hours. It is amazing, the pollution. Okay, then this is costing, in terms of health costs, around, or right now, around 64.1 billion euros a year. My friends, 64.1 billion euros to treat diseases. Okay, so this is a big impact, has a big impact of the populations. So also it is intention of the European Union through the MRV that there will be the engagement of the shipping on the emissions trade scheme. Okay, so this is a cap and trade system to maritime transport. It is one of the top political priorities of the European Union. What I'm trying to say is, I have to agree with this. The way what is going to happen is that per ton, people will be, the ship operator will be charged, and per CO2 ton. I have to let you know that approximately for each ton of heavy fuel oil or diesel oil, you will be producing about 3.16 tons of CO2. If you imagine that each ton of CO2, it is now valorized at 24 euros, okay, so per each emitted ton, you have to pay to add to your operational costs a tax of 24 euros per ton of CO2, then you realize that this is a very strong, how to say, tool to make the ship operators to care about efficiency. Okay, so this is very important for us to keep in mind that extra taxes will come in a very short time, and they are not. These taxes are not light taxes. These are very heavy taxes. Okay, so the thing is, in terms of emissions, megatons per year, we can see that bulkers and container vessels are the big emitters, okay? And then you say, oh yeah, okay, but we are so efficient. Yes, we are. When we are dividing the fuel consumption by the amount of tons of cargo that is transported. But if we compare the international shipping emissions in terms of million of tons with emissions of many countries, then you'll see that we are in the 6th position. Okay, if the international shipping is considered as a nation, okay, so we were the 6th bigger emitter of CO2 and other things in the ranking of the nations. So the argument that, oh no, you are not a friend of shipping. No, we are very efficient. Yes, we are, definitely. But in absolute figures, in fact, we are the 6th bigger polluter in the world, okay? So these two, we know, but China is the factory of the world, unfortunately, and has this problem. So United States, we know, 3,000 cubic centimeters cars are quite common. And then we have the other ones. So no comments. A very interesting, a very interesting graph is also this, or table. So around Europe, people decided to start stopping, closing down the coal plants, okay? And here we see the quantity of coal plants that have been closed down, okay? In Germany, mainly. And then suddenly it appears here, the Mediterranean Shipping Company. Wow, so is the 8th bigger European polluter. Fantastic, isn't it? It's a surprise. Then the guys of Ryanair, the low-cost company. So, in fact, we need to see these numbers from this perspective and understand if we are effectively doing well. I believe it is a surprise for most of you. Okay, this was the ship traffic in 2017, and the fuel consumption per grid. As you can see, we have all around the coasts huge quantities of consumption of fuel, because most of the ship are not transocean, but is deep sea. In fact, we have here what is called deep sea, a little bit here and there, but in fact, most of the routes are just around the coast, and people is dying because of this. Okay, now, no doubt, but how large is the are the shipping emissions in 2050, and this was a projection from DNVGL. So, well, the consumption of oil was somehow curbed, while the consumption of other forms of fuel were increasing. But the thing again is, so this was a projection before the pandemic. I believe after the pandemic, everything will be changed. So the rules of the game have been changed. But so natural gas that everybody was expecting, wow, is going to be the future, may not be the future as we wish. Right now, there are in the whole world, there are only around 180 ships with gas propulsion. And is the gas propulsion, in fact, a big thing? So in terms of emissions reduction, I don't know. For particulate matter, yes. For CO2, not that much. So regulating bodies, the most active regulating body is the MRV of European Union. Okay, so any ship bounding to European waters need to be compliant with MRV. So they need to have all the reports and all the measures in place. IMO, EEDI, and EEOI and SAMP, well, that is another game. So what I want to stress is that have been a big effort to from many lobbyists to implement the IMO only and to leave the European Union MRV to die away in the time. But it looks that it's not going to happen like that, especially because these lobbyists want to control. They want to be business as usual without investing on shipping. So shipping is just about, is more than 100 years with the same type of propulsion plant and practices. Okay, so we had the sail, first we had the rowing boats, then sailboats, then coal boats with sails, then only coal boats, then diesel boats and gas turbine and turbines, steam turbine boats. But now it's time to change. Okay, now it's time to change. We have to be honest, so we should not do like the ostrich that puts his head inside of a hole. We need to look at our populations and our planet. Okay, so the difference, one of the points of MRV being in charge, in power, is that there are a lot of how to say distortions on EEOI and EEDI. You will see. So basically, EEDI, Energy Efficiency Design Index, is to reach at design stage a measure of the carbon emission per nautical mile of a certain ship and propulsion plant, whereas the EEOI is the Energy Efficiency Operational Index, has the same unit, so grams of CO2 per ton nautical mile, but it serves now as a comparison to EEDI. This EEDI became mandatory for new ships, as well as the SEMP for all the ships for all the ships according to the MEPC 62 July 2011. Let's see. Passenger vessels. So the big point is that the CO2, so the EEOI, may be defined as the taste of the user. Okay, so it should be defined as grams of CO2 per passenger nautical mile, for example, for passengers, passenger ships, cruise ships, and RoPax. Okay, oil tankers, vehicle carriers, whatever, should be grams of CO2 per nautical mile or per lane or per number of cars, but should be fair. For LNG carriers and other cars and other ships, maybe grams of CO2 per cubic meter nautical mile. General cargo ships, grams of CO2 per deadweight ton or per ton, sorry, nautical mile. So this is a very complex formula. I'm not going into it, but just to let you know that the things are somehow complicated, as well as, so it was so complicated that it became a simpler way of making up this formula at design stage, okay? And now just mention one thing. So specific fuel oil consumption at 75% MCR. So how many of these ships are making 75% MCR? Most of them in the real world operation are not doing that. They do other how to say, engine loads that affect the specific fuel oil consumption that has, you know, it is a parabola and has a minimum around 90%. So this is posing a lot of contradictory things. Regarding the stated or declared and the real world, okay, so we have a number of vessels. As you can see, the companies are here. This is public. So as you can see, imagine we can see the difference between, for example, Hapag-Lloyd. Hapag-Lloyd, the 8th, has 65 ships, and the average EEDI was 18.29 grams per deadweight per ton nautical mile. And now, comparing it, we can see that Hapag-Lloyd, in fact, is not 18, but it is 21.13. Or, so this is to show you that between, for example, COSCO stated 13.74, and we can see 13.24, but these are Chinese numbers, okay? So these, please don't laugh, believe me. So these are Chinese numbers. So they comply always. They even do better. But then looking at other companies, MSC 16.31, they have 19.92. CMA 16.33, 20. So what I'm trying to say is, in fact, people is not doing it by purpose. Is that what is happening is that the operational conditions of the vessels are so different than the ones at design stage that very hardly these figures will match, okay? So the theoretical, so the EEDI and the EEOI. Hope you, to make this clear, okay? Fantastic, isn't it? So, for example, you can see for the express feeders group, 29.36, 43.05. So this is not, nobody's cheating, but somebody at design stage did not address this problem of operational conditions properly. Okay, so for example, for the Carnival cruise ships, on paper, so the grams of so EEDI say, then we can see the real world difference between what is declared and what is in fact happening. So the emissions of these type of vessels are absolutely crazy. Okay, so these are really a big problem. Then there is another point here, is the way these big companies are hiding or manipulating their figures, like grams of CO2 per half kilometer. Half means one half is a cabin with two people that they assume that is full of two people. So should be, how to say, standardized to assess everybody. Not going into equations, but just to mention something that is very easy to understand. So the total energy requirement of a ship is the energy for propulsion plus energy for the auxiliary energy. Okay, so then we can divide the auxiliary energy required into thermal and electric. Okay, and then if the auxiliary requirement thermal may be defined as a threshold energy that is necessary to put, is the minimum of energy in terms of energy, of thermal energy. That is a function of the power of the propulsion engine, and also for the propulsion is exactly the same. So this means that the selection of an engine with a certain power calls also for a certain auxiliary power that should not be neglected. Okay, and these are linear functions. Okay, now coming into this is from a study of IMO. So it was not created by me, for a small feed vessels, container vessel, a feeder, and believe me, this is telling you about everything. So from a hand, and this considering only for the propulsion, okay, not considering auxiliary power. So from 100 tons of fuel, you will be throwing away 30% to the environment, to water, okay, by cooling. So 30% goes to mainly to water, okay. Then so 30 tons, you just dump them into the water. 30 tons equivalent of energy, and 270 tons equivalent of energy you throw it to the environment. All right. Then, in fact, what you are effectively transmitting to your shaft is 43 tons, from which you, depending on how well the propeller is matched to your ship and your ship operation, then you will get only 280 tons transformed in useful work. I want you to draw attention to this. Where or should we not recover it and put it back into the shaft, or recover it also from the exhaust. You know, these are costly systems, okay? And these costly systems should be implemented because, you know, shipyards want to sell or to offer a very cheap ship. But when they are offering you a very cheap ship, then you are, how to say, assuming that you will run the inefficiency of your ship during all the ship life. So you get a very cheap vessel, but you will run with the inefficiency of those vessels all along its life, okay? For example, and giving you a very interesting example, shipyards, when you specify, I want to have an heat exchanger in titanium, so the main heat exchanger, seawater heat exchanger in titanium, this is quite common. But if you specify this only, so from the point of view of the shipyard, they will deliver you the titanium heat exchanger with a very small heat transfer area and with a big pump with a pump with a high flow rate to compensate. However, so your request is completely satisfied, but from your point of view, that you are not interested into it, you should be interested in to have a high transfer area, so a big heat exchanger with a small circulator seawater pump, okay? Because you will be paying the check for your pump during all the ship life, okay? This is one of the things that we have been doing on board ships with quite a big success. So, in fact, ship has an energy system. We can manage, you know, of efficiency, especially because a great mistake has been done during our last century practice. The propeller is optimized is matched to the engine for the sea trials, okay? But ships are not operating anymore on the sea trials conditions. In fact, we should match our propeller to the operational routes where the ship is going to be in operation, or at least we should have data sufficient to do that. This is one of the things that with our BOEM-S system we can provide. We can characterize the routes. One other point here, for example, is that engines are rated to a certain power that they never operated. So you need to do a statistical study of the engine loads and to derate the engine loads, so to match to derate the engine to match your operational loads, okay? So this is another exercise that people should do in order not to scrap the engines or deteriorate the engines quickly and have better efficiency. So as I really enjoyed these photos. So this is how we do or we have been doing our designs. So we have been eating the oceans. It's fantastic, isn't it? These are infrared photos that I took many years ago. So this is an LNG ship, and this is a tanker. Fantastic. Just eating the fishes they like. Anyhow. Okay, taking this from MAN. Now, looking at this, we have enormous quantities of energy flowing out of our engine. This is one of the bigger engines around, the 12K 98. It's a quite common engine for container vessels. And then if we look at this, oh yes, this is just 25.5% of energy. Or looking at the air cooler, oh yes, it's just 16.5%. But if you look at how much in terms of energy this represents, you are dissipating a power of almost 2 megawatt for the lube oil. You have for the jacket water cooling 3.5 megawatt, exhaust gases 17 megawatt, air cooling from the intercooler, you have air cooler, you have 11 megawatt. This is crazy, you know, not to take these energies back to where it belongs, to be used, not to be dumped, okay? Anyhow, most of the ships nowadays are still doing it, just dumping it. Oh yes, we have no load to receive the exhaust gas temperature. We have no heat. We have no loads to use the air cooling system. Dynamic matching is fundamental here. Okay, improve engine design, the systems integration. Okay, so system must be dynamically matched. It's not matched for the sea trials or whatever. Okay, power plant systems integration and energy recovery. Okay, you should know exactly what is your optimal speed by having data to analyze. And then we have the penalties that come on EEOI and MRV and etc. Okay, port operations efficiency, just in time and integrated logistics. These are huge areas of savings of money and savings of the environment. Okay, now going to the fuels with existing ones. So, well, we are now in an environment where you as ship operators will be completely puzzled. So many people went through the scrubbers. So 3 to 4 years ago, scrubbers were looked at as the big thing. Okay, we can we do the investment in the scrubber and then we can go as before with the same fuel. Now the scrubbers are being looked at over the shoulder. So people is not really enjoying or fancying that much the scrubbers. Legislation is just around, so people cannot throw into the sea what they used to throw into the sky. One other point is most of the ships do not have, remember this, sufficient available electric power. So from one side, we are saving, how to say, complying with the SO2 emissions, but from the other side, we need to produce more emissions because we need to run our auxiliaries eventually to, or most probably to run the pumps of the scrubbers. Then some say, okay, natural gas. And I say to you, look, do you think natural gas is the answer? I can bet with you that natural gas has a bigger carbon footprint than heavy fuel oil. And you say, why are you crazy? No, I'm not crazy. When you bunker fuel oil, you are bunkering a subproduct of a refinery. Okay, so you are bunkering a byproduct. However, when you are bunkering natural gas, that is, you can see here the emission factors. In fact, you are bunkering a product that was produced with a lot of energy being wasted and liquefied and transported with a lot of heavy fuel oil, probably, and gas. So the footprint associated to natural gas, it is amazing. Okay, so we need to be very careful in the European Union. That's why there are so few ships around the world, and most of them in Norway and Japan. So nobody wants to have this, also because of the cost of the bunkering installations, availability of infrastructures, and the cost of the bunker system on board. It is prohibitive. The other point is diesel oil as bad as heavy fuel oil? Yes, diesel oil has less sulfur, but however, emits a little bit more of CO2 than our crap and horrible RMK. Then other ones came, oh no, we have now the methanol. Methanol production facilities are very few. There is no sufficient methanol to deliver to all the ships. And then you see here one very important point, that is, we have methanol net calorific value is just less or slightly less than the heavy fuel oil or the diesel oil. So you need to have twice or more than twice the capacity, the bunkering capacity on board your ship to run a vessel with methanol. Okay, this is something that needs to be very well addressed. So you need to have the double of the mass on board to have the same energy stored as you have for a diesel oil. Then other guys come, no, now it's time for ammonia. Ammonia is the best. Ammonia is a solution. Yes, it may be one, but there is only one point. So in terms of ammonia, we are talking about almost the triple of the calorific value of diesel oil. That is fantastic. But again, has the natural gas and methanol to produce the 1 kilo of methanol, you need to produce to use about 38 megajoules per kilogram. So the production of ammonia is not carbon-free application, say. So ammonia to be produced in large scale, as it is in the United States, they have also pipelines of ammonia, but you have to produce it according to one cycle that is called Haber-Bosch through the reforming of natural gas. Okay, and this calls for a huge emission of CO2. Okay, ammonia has a strong impact, beneficial impact, positive impact in terms of emissions. It will emit a lot of NOx, but for the NOx we have the catalysts. However, if we have some slip of ammonia, you will have the accumulation of, or how to say, the ammonia at the atmosphere. So it goes from NH3 to NH4 and will accelerate the existence of particulate matter. Okay, so this is a promoter ammonia is a promoter of particulate matter. And this happens during the overlapping time of the cylinder valves, okay? Then we are left with hydrogen. Hydrogen, great. And how is it great, or why is that great? Hydrogen in its liquid form is 120 megajoules per kilogram. So, but if you are meant to have liquid hydrogen, you will be wasting about 1/3 of the energy to liquefy it. And that may not be the solution. Although most of the gurus say, no, this must be liquefied or compressed to 700 bar. This is simply not feasible because of the price, the cost of the installations, okay, on board. So we need to have hydrogen on board, or the solutions are three right now. Because we need to understand that the ship propulsion plant needs a lot of power, okay? So that cannot go with fuel cells. Fuel cells are expensive, are not reliable, and they do not have the power to deliver for the propulsion of a system. They may be utilized on auxiliary systems, okay, fine, but not for propulsion. So the powers involved are too big. So the idea, what I'm trying to say is hydrogen can be produced anywhere there is sun, for example, or anywhere where is wind. So this is, in fact, a possible solution. We have to have a possible solution. And right now I'm working here in Europe was released a program for research for using liquid carriers or whatever carriers, all the value chain for the hydrogen. Europe is now doing a lot of effort on this with vast amounts of money. So regarding the criteria to select a possible marine fuel, you should consider the technical, so engine adaptation, pre-treatment, maintenance, fuel properties, the economical, the investment on bunkering systems, how much is going to cost the fuel, and the operational costs. Then, especially in terms of safety and handling, how much is going to cost this? Okay, the logistics, where can I bunker my ship? So, and then please think around the environment. So ships need to be environmentally friendly, okay? The fuel handling spills, so everything needs to be understood in advance in terms of life cycle, environment, and performance. Okay, because if you are about to make to build a new ship, at least you should think about what is going to be the society requirements for my ship in 20 years time. Okay, so the idea is now the difference between the theory and the practice. So for the crude oil, we have crude, and crude is a fantastic product, and heavy fuel oil, EFOs, marine diesel oils, marine gas oils, all these are byproducts. Okay, so the carbon footprint of crude oil is divided by all these products. We can burn them, as you know, in these plants. The coal, the nuclear. How is nuclear here? Nuclear is coming to help water electrolysis. So nuclear does not emit any CO2, any emissions, if it works properly, and hope not radioactive emissions. Okay, so let's talk about a proper maintained nuclear power plant. So these are the guys that can produce a lot of water electrolysis and a lot of hydrogen. And we can burn hydrogen on diesel dual fuel engines, on gas turbines, on boilers and auto engines. So hydrogen is very well suited to drive these engines, okay? People that say, no, hydrogen cannot be burned in diesel engines. Yes, it can. My PhD was around it. The use of hydrogen as a fuel for compression ignition engines. Then we have other ways of producing, but these vegetable oils are competing with the food area for people. And then we have wind, sun, so the renewables. And again, we have the same end users for hydrogen. So hydrogen is on top of the list. You have no fuels, in fact, without hydrogen. You may have carbon, pure carbon, but you need hydrogen there. Okay, so in terms of conclusions, it is urgent to reduce CO2 emissions. There are various ways of tackling this problem through the operation and good operational practices. But everybody needs to have a new mindset, okay? And new mindsets means being alert for the problems that we are suffering and will be suffering in a very, very quick time. You have been with difficult storms, like China with very difficult storms, United States even bigger. So people need to think about that we live in the world is our common house. Okay, so we need to keep it. You should be also aware that the cap and trade system will be put a lot more of cost on the ship operations, and the way to go around this is through the energy inefficiencies. Okay, so tackling energy inefficiencies, and remember that a very cheap vessel that make you to make money very quickly. It may not be the good bet for the future. So you will be paying the vessel inefficiencies for all your life. So then the carbonization of shipping is not resting only with ship owners, and the competitiveness of the shipping companies is a lot related on how you are well related with the other shore players and business players. So ship owners, ship operators should put a lot of effort on the ports calling for their digitalization. As we did here in Portugal, we are proud to have what is called the open wind window program. So it deals with all the paperwork and inspections and whatever a lot before the ship is arriving. So when the ship is arriving, it can arrive at the right time with all the paperwork done, agents done. So everything is done to make it to flow. One other aspect here is that, as you know, power of the ship is proportional to its speed to the cube. Okay, so the shaft power and engine power, okay, so it's proportional to the speed of the ship to the power of 3. So any small reduction that you do in your ship to get just in time, then it is reflected on your bill, fuel bill and emissions. Also, it is important to understand the fuels well to the propeller, not the only from the bunker to the propeller. The higher is the power of propulsion plant, the higher is the power of corresponding auxiliary machinery originating by proportional emissions. So remember that ports are now calling and putting some taxes on top of this. Okay. Energy recovery systems and systems integration should be installed. Mainly, you may use organic Rankine cycles to produce energy and to store it in batteries for your port stay, for example, or to produce some hydrogen for you. So one other aspect of hydrogen, and I just remember now, is hydrogen for internal combustion engines do not need to be of high purity as it is requested for fuel cells. So our engines, reciprocating engines, marine engines, they burn everything. Okay, they eat any type of fuel. Okay, so you don't need to have a very high purity hydrogen as you require. And these hydrogen, so the purity, high purity of hydrogen is putting on top of the price of hydrogen per kilo between 20 and 25% more. Okay, so to get a fuel for hydrogen for burning in a diesel engine, you have one price, one cost, about say 4 euros per kilo, and with some technologies even lower. But if you ask or you require a high purity hydrogen, then you have to add at least 20%. So you have 4.8 whatever euros per kilo. When the quantity of hydrogen is too much, it can be burned on your main engines as well. So in a business as usual scenario, heavy fuel oil and marine diesel will be on board most ships beyond 250. But with the strong force that the European Union is doing, and other countries out of European Union are start looking at and need to comply if they want to come to Europe. I believe this will be changed. Well, I'm just about to finish. The impact of decarbonization will be much stronger than the impact of ultra-low sulfur fuel. So it will cost a lot more to the ship owners than the change to the shift to low sulfur fuels. So, and believe me, you need to identify these things. The impact of in the health of the populations. Also, you should look at the integration of innovation in innovative new technologies. Hydrogen, it is a vector that you cannot go away. So think hard about this. The nuclear power will be hand to hand with the production of hydrogen, because the quantities of hydrogen are huge. The main problem right now for the hydrogen is how we should store it. And we will be, my company and another company will be coming out soon with a solution for that. In case there is an urgent need of developing cost-efficient hydrogen production, as well as improving technology to overcome the possibility of enrichment of materials. So materials need to be special. So any engine can burn hydrogen, but it must burn it with a certain care or up to a certain concentration in terms of percentage that is burning. Okay, so I believe that's also one important thing is commercial deep sea vessels are not exactly compatible with fuel cells because what I said before, they are not, they are very expensive, they are not reliable, and they have no way to develop 60 megawatts or even 6 megawatt of power for the propulsion. I believe that right now the bigger fuel cell around the world is 10 megawatt, and it is a nightmare. So remember this: fuel cells, yes, for very small applications like port loads or something like that. It is important that port operators and ship operators, shipbuilders, everybody works in team to reach the goals of the greenhouse gas emissions reduction for the long distance. And designing a vessel, the design should be, you should think about it in terms of future. And the future, the design should be based on the route that you are about to use, not the route that not designing the vessel for the sea tribes. Okay, so this is very important. Just to finish with one story, when I did my Master of Science at Newcastle University, I remember one lecturer, Mr. Tom Roxton, a fantastic guy, and he was saying that one of his lecturers was fired because he have designed a propulsion plant with a gas turbine to operate in Africa. And while the ship was here around Europe with cold air, everything was fine. But when the ship was sailing to Africa, the power was not sufficient and the consumption was really difficult. So we should match our ship design where we want to operate as far as we can. Thank you very much for your attention. It was a pleasure. I hope this presentation just switch on some lights, or I wanted to make myself available for any question you may have. Thank you.
Yeah, thank you, Dr. George. Very good afternoon to everyone. An excellent presentation, Dr. George. I think it was very engaging. Well, we are quite behind schedule, so I will, without wasting time, I will jump. We have several questions, but I don't think we'll be able to take all of them. But yeah, a few of them we will take it up now, and rest we will answer via email. Well, the first question I would like to ask is about the two software tools you mentioned, Dr. George. That is the VEEO and the BOEM software tools. If we look at most of the vessels which are now in water, they are the reporting that happens, whether it's the noon reporting, the fuel oil reporting, the consumption, the speed, etc., still largely manual. That means it's people who are reporting it. And you did mention in your slides very rightly that human behavior is a very important aspect, and when we are collecting the data and how we are able to make sense of the data. So how are these tools able to take into account the possible data inaccuracies that are coming into play? Yes, when there is no human intervention, it's all direct digital reporting, direct to the software, possibly, it may not be that big a concern. Yeah, Dr. George.
Well, thank you for your question. That is a very pertinent one. In fact, human factors are the main problem around the reliability of data. Also, in data is like a big iceberg. Okay, so the information is on the data, but data has a lot of noise. Okay, so in fact, we need to assess the ship data and to filter it to extract the noise. Okay, so this is it's like we need to do what is called data mining. So we need to take the information out of it. In fact, the system VEEO is dealing with is trying to shortcut this by having very reliable information systems like Coriolis flow meters properly installed, and also AES information. So what this is doing is merging the right data, filtering it, and analyzing it. So nobody needs to analyze it to have to be crashing numbers at your office or on board, because the data is just prepared, ready to go, ready to be sent to the decision stakeholders on this. What is the data? Say, the other point is data may be treated as you wish in according to your company's parameters. So, but the data that is going to be delivered to for the MRV, it is treated according to MRV how to say standards. So that is the idea. So the idea is to minimize the maximum the work for people on board and the shore. To have you just need to say and to establish, this is the way I want this data. These are the parameters we want. So this is the system. The system learns how you want it. That is the idea.
Yeah, understood. One more question towards this, the software tools again. Pretty interesting slides, I should say. My question, the question would be like, would it be possible for the technical managers or the ship owners to evaluate or pinpoint whether, let's say, there is an increase in fuel consumption, whether it is due to hull fouling or propeller-related issues or fuel injection system issues? Can you infer from the data what is the increase in consumption due to?
Definitely. That is one of the outputs of the advantage of having this data, is that you can manage and to get the information regarding the points that you want to check. For example, you may, if you have the torque, our OptiPower system. So if you have the device that is measuring power, the power delivered to the propeller, and the thrust, so and the RPMs, then you can pinpoint if the problem is with your fouled propeller. If you are delivering more power to your propeller, okay, and the thrust is becoming lower and lower, then you have a fouled propeller or a problem with your propeller. However, if for a certain speed you have if you have for a constant for a certain speed, if you need to put more and more thrust, then you have a problem with your hull. So you have a fouled hull. So you need to clean the hull. And for this, you may set the alarms. Okay, I am willing to know to run my ship up to a certain level of efficiency of the hull, and above this is costing me too much. Better to put one guy inside of the water to clean the hull. So these are things that may be very costly effective. But you need to have thrust and power measured at the same time, and eventually consumption. So these are two KPIs that I just mentioned. So thrust divided by power is a KPI, or speed divided by thrust. So it is another KPI that you can monitor along the time, so that you can monitor your hull efficiency or machinery efficiency. Okay.
Thank you. Very, very lucidly explained, Dr. George. Well, the next question I was going to ask was, I think you already mentioned that this EU MRV and IMO DCS are two parallel reporting schemes that are happening. And ideally, ship owners and operators would like them to merge, because it's a sort of a lot of duplication of reporting that's happening. Yeah. But you mentioned that's not likely to happen. I do understand that it's a reluctance on part of EU. Any reasons why? Yeah.
Okay. So that is it is a very, very problematic question. The thing is, IMO is IMO. Okay, all the countries of European Union that are sailing countries, say marine countries, say belong to IMO. Okay, are members. But the thing is, the progresses of IMO have been so slow, so small in terms of results and implementation and requirements, that European Union said, no, we don't like this. Better to have our own system that at least it is reliable. I have to tell you that to become a verifier, we need to be accredited not only by the European Maritime Safety Agency, but also accredited by the international standards. So according to ISO 4065. So it is really difficult to become, so they are putting a serious engagement on this. On the other hand, if you look at this, and sorry for the ones that belong to classification societies, we have classification societies that have the side store just there, and they do IMO, DCS, they do everything. And it is very hard for a ship owner not give that service to the classification society, for the classification society to do, okay? And then, you know, the inspection organisms, the IACs in particular, they work very much like this. So they are independent up to a certain point, okay? And everybody is giving them the IMO DCS as well as the MRV, but the MRV is totally independent and has its own platform that is called TETIS. And on TETIS, everything must be properly reported. I don't know how the other companies are doing that. I know that we have one audit all the single years with two guys from EMSA, so it's not easy. So we keep to keep all our records and historic records of the ships, etc. So it's very, very hard to do it. Very how to say, exigent, I would say.
Yeah, thank you, Dr. George. I will take just two more questions because
yes, please go ahead.
Much time. Yeah, see, very, very valid question that was raised was we have had the SEAM 1 for quite a long period of time now, where ship owners had to voluntarily make commitments on how much fuel consumption they will reduce on a year-on-year basis and from what. So, but then, but there was no sort of legislative requirement that came up either from IMO or or even from EU for that matter, on how this is verified to ensure that our ship owners actually doing it. So the question was, wouldn't that have been a better way to go to faster, what shall I say, ensuring that compliance towards reduction of emissions?
Yeah, that is a good question. In fact, I believe the first cycle of MRV is just about to finish. So right now, MRV has been, how to say, polished, fine-tuned, and now the fleet has been characterized in terms of emissions. Okay, so things are becoming more well-known. The other point is, okay, there will be two ways of making the ship owners to understand that they need to reduce as much as they can. One is by the imposition of carbon tax, and the other one is by the imposition of port taxes. Okay, in Europe, it is quite common right now to charge the ships according to their EEOI. Okay, and also it is important to, most European ports are looking at the ship recorded MRV. So you see, you have two mechanisms to make people to think about it. You either want to pay, and please keep this number in mind. For 1 ton of fuel that you burn, of heavy fuel oil or diesel oil, you will be emitting about 3.2 tons of CO2. Okay, each ton of CO2 costs you right now about 24 euros a ton. Okay, so you can see how fast is this bill growing if you are not efficient, right? So this cap and trade system, emissions market, is going to be the instead of putting a level, no, you have to reduce next time this. This is going to push people to think twice before the thing. Anyhow, there is one way of setting for each ship the possible reductions. Okay, so a reduction of energy should be considered in the basis of an energy audit, and then by establishing then through a formula, establishing a limit to reduce all the next 3 years. This is one way of doing it internally. One very good way of making this is by using the ISO 50,000 series. That is energy management for companies. Okay, ISO 50,000 series. So that may help.
One last question, Dr. Jaj. You had mentioned in one of your slides, of course, there is a lot of debate on this issue related to use of LNG as a fuel. You mentioned that that LNG, the carbon footprint of using LNG would be probably more higher than heavy fuel oil. But having said that, there was a very, or at least a point that was raised by one of our members, which was that LNG, of course, has a higher calorific value as compared to heavy fuel oil, but also there are other things like in the entire system, like purifiers may not be required, heaters may not be required, which are required to heat the fuel oil. So some of these, and then the LNG itself could possibly be used as a coolant for various other processes. So wouldn't that, all these put together, make it a little bit more worthwhile fuel, at least for the, what shall I say, intermediate future till sort of a zero carbon fuel comes into being?
Yeah, that is a way of seeing it. In fact, You don't need to carry purifiers for the heavy fuel oil. Although there is one other point here that is very important. Remember this. Auto engines, so spark ignited engines, usually they have other disadvantages. One of them is for maneuvering. So maneuvering, the torque availability at low speed is quite weak, and they tend to somehow not to start as the captain wants, or there are some issues regarding the maneuverability. Okay, so I found that very interesting in terms of having diesel electric propulsion, fantastic, but direct coupled may be very questionable. Okay, so that's why most of them, they do maneuvering on diesel. One other aspect, in fact, is, okay, you don't have the engine purifiers, the heavy fuel oil purifiers, but then you have a huge amount of cost for your bunker system on board. Is more or very close of the price of the rest of the propulsion plant, depending on the capacity. But you know, the price is prohibitive. And if this is such a good how to say, solution, why we have so few vessels around? Okay, so we need to understand it is not going to be the solution for the future. That is for sure, because in terms of emissions of CO2, we do not have that less emissions of CO2. So 3.1 kilos of CO2 per kilogram of fuel for the heavy fuel oil, and then you have 2.70 something for kilogram of natural gas. So the difference is not that much, and the cost and complexity of a ship on LNG, it creates dependency on the gas. So one thing that I advise you: never have one ship main engine running only on natural gas. Ships should have at least dual fuel. If not, you'll be on the hands of the natural gas provider, or you may need to operate your ship in a different route where there are no supplier. So there are a lot of variables here that you need to put on the table and think about it, especially in the future.
Thank you, Dr. George. So we are already far behind schedule. I will pass on to Mr. S.M. Rai, who is our senior fellow of the institute and a very learned person as well. Mr. Rai, may I request you to summarize the session?
Yeah, thank you, Mr. Girish. And first, my thanks and compliments to Dr. George. His presentation has been so informative and educative and so elaborate. I don't know where to start to summarize this. So it has been really a learning experience for most of us. And I really would like to thank you for all that. I would only summarize in two aspects that in your presentation today, you very ably covered both the aspects. One was the competitive business segment and what needs to be done for ships operation to be competitive in the current challenging market. And secondly, you dealt very well with the environmental issues that relates to your carbon, GHG emissions, etc., etc. In the first, you highlighted about the various software that are available. I am only happy to share with you that most of the ship owners are currently effectively utilizing those softwares, but there's certainly a room to improvement. We well noted your submission that vessel optimization is a vital issue to be competitive and reduce the carbon emissions. I would, in that context, as far as your environmental issues are concerned, global warming, reduction of increasing temperatures by 1.5 degrees centigrade is yes, bothering the industry as well as the IMO. I'm aware that you as well as the entire industry is aware that 1st of January 2020, we have already adopted to low sulfur fuel. You dealt about European Union and IMO looking at various aspects. I do agree there is a lot of difference opinion, but IMO also considers the views of the developing nations, because many times developing nations are not financially or technically capable to take over those changes. You are aware about Kyoto Protocol. There was a room that some financial addition or aids must be given to developing countries, which many people eventually later refused. Even in the Paris Agreement, I'm sure we all are aware that even United States later on walked out of the entire agreement commitment he made. So we have taken into a fuel alternative. I'm sure we will have some more interactions with you, or we may invite you in future. We'll be more interested to know what are the alternative fuels. Two very interesting options available today, as you also pointed out. One is hydrogen. And of course, you didn't dealt in detail about the autonomous ships. So I will be more interested to know about adoption of hydrogen as a fuel, ammonia, hydrogen, and maybe the autonomous ships. Further, just to conclude my summary, because I will not like to take more time, we would also be interested to know what is your marine fuel path progress. You explain in one of your slides that there is a fuel path already being worked on. So if you can keep us updated on your progress on the marine fuel path. Also, how you propose to integrate the operating practices integration. And of course, as I said, carbon footprints, what is there? Lastly, I would also like to know what you think about the future of carbon trading, because that has been debated for last nearly a decade. It was taken up even on IMO as well, but nothing concrete has come out of carbon trading. Today, I know we are short of time, but we'll certainly look forward to inviting you in future when we like to deal with those. So that's all I have to summarize and say. And thank you so much, Mr. George.
Thank you very much. I really appreciate the attention and your time to listen to this. One thing, just to reply to you with this last one, is to Mr. Surendra, right? I believe that everybody will be pushed somehow to comply with this if they want to come to Europe. So ships bounding European ports will be pushed to comply. And this is just there is one other aspect is that if you come to Europe once a year, okay, it may not be a big deal, but so you're just paying, that's it. But coming to here for many times a year, then it is a big bill at the end of the time that you have to pay. One other aspect regarding your comment, Mr. Surendra, is for the developing countries, is you should tax somehow, and to arrange from this tax somehow the emissions and the efficiency, giving a price to the efficient ship owners, and you should tax somehow a very small amount of money and create a fund for research and development. Okay, so with these taxes, you eventually can produce research, you eventually can help projects to be implemented on your country's vessels. You get the idea. A small tax, but it may make a fund to promote the ship efficiency, and that's all. Sorry this is just one.
Thank you so much.
You are welcome, sir. Thank you to all.
David, all yours.
Can we?
Yeah. So I think Sanjeev, we can do the poll.
can we ask Mr. VK Jain to give a word of thanks, please?
Okay. And poll also, we can same time.
Thank you, David. Thank you, Sanjeev. Yes, maybe we can conduct the poll whilst I'm doing the vote of thanks to save some time. Dr. George.
Yes,
thank
yes.
you very much for your interesting and most wonderful lecture.
Okay.
One of your sentences is still resonating in my mind. The world is our common house and let us look after it.
Yes.
What you have talked about is a very topical subject. Unprecedented climate change is hitting us all, whether it is cyclones, extreme flooding, rain, cold, hot weather, and it is all up to us to attach importance to take steps to overcome or mitigate the effects that are causing this climate change. Indeed, it has been challenging to narrow down the vast subjects that we have seen and heard you deliberate upon today. This would not have been possible without the active involvement of retired Commander Alok Bhagwat, Mr. T.S. Girish, and our Honorary Secretary, Commodore Bhupesh Tatir, who have constantly been working behind the scenes with you to bring this important subject to us. My thanks are also due to Mr. Damaji Mahavalankar from Goa, who has supported this idea from the very beginning and agreed to sponsor the event. Thank you, sir. Contributions of Mr. David Berwadkar and the omnipresent Mr. S.M. Rai have been extremely valuable. No event of this magnitude is complete without the untiring work of our team in the background, comprising of Mrs. Neeta Nair and Mr. Sanjeev Mehra. Finally, I thank all participants who are present here today and having actively participated, apart from sending us very interesting questions in advance. Thank you all and stay safe. Sanjeev, is the polling done? Can we have the results or is it still going on?
Yes, sir, it's happening. You and me will not be able to see it. So
just give me about 30 seconds more. I have about a response of 50%. I would like to come to 60 and then I'll publish the poll result.
Yes, no problems on that.
So just everybody, please do not leave before that. Thank you.
Must make mention of thanks especially to Aakruti. If we have the slide, but nevertheless, even if we don't have the slide, many thanks to them for sponsoring our program and making this happen today.
So I've shared the poll results. Is it visible?
Yes, it was.
Thank you so much, sir, from Aakruti.
Much grateful, sir. Thank you so much.
Okay.
Fantastic results. Congratulations to the organization and to the Institute of Marine Engineers. Very good, very good. Very good. Thank you very much.
Thank you.
I must say this is the first time we have had somebody from abroad addressing us like this. So many thanks for a different perspective, sir. Thank you so much.
Thank you very much. Fantastic. Congratulations.
Then one thing, I'm seeing some queries regarding the online course. I request them to send the queries to Mumbai at imare.in so that we can answer the questions at length and give you elaborate answers rather than on the chat where it may be brief. So please request you to send the question by email to our Mumbai branch and we will answer it as soon as possible. Thank you.
You have my email also on the presentation if somebody wants.
Definitely, we have some questions which have come in and we would be sending them to you, whatever we could not answer in the times.
Okay, thank you very much.
Sanjeev, are we ready with the national anthem?
yes, sir. I will just request everyone to please raise for the national anthem. Oops. One second. One second. I lost it somewhere. Just hold on.
गणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you all. Thank you.
Thank you so much, everyone. Wonderful.
Okay.
Thank you, sir.
Have a nice Sunday, everyone.
Bye-bye.
Thank you. Thank you, sir.
Bye. Bye-bye. Thank you.
Thank you, everybody.
Sir, Chairman sir, can we close?
Yes, please.
Yes, please. Yes, sir. Please. Thank you so much.
Bye.